Bonjour. For 8.2, we're talking about how to graph ax squared plus c. So it's basically what we did for 8.1, but now we're adding a constant to it. So if you want to pause the screen and take a look at what we're going to do, go for it. I'm going to jump right ahead into the lesson. Here we go. So anytime you have f of x equals ax squared plus c, again, this a is going to determine whether our parabola, our u shape, is going to go up or down. Goes up like this if it's positive, down like this if it's negative. And then if a is a fraction less than 1, it's going to flatten out. And if it's a number bigger than 1, it like vertically stretches, squeezes in. The c value is just going to move the graph up or down. It changes the y-intercept. So it just moves the graph up or down. Okay, and that is shown right here, which you're going to take some great notes on right now in your notebook. All right, now that you've taken some excellent notes, let's go through an example of this. So if we're graphing g of x, which is x squared minus 2, basically x squared is going to be a parabola that goes right through 0, 0. Right through 0, 0. Okay, so let's say that we have f of x, which is x squared, and it's this parabola that goes right through 0, 0, goes through 1, 1, 2, 4, so it goes through right about here. What's this x squared minus 2 going to do to this f of x equals x squared graph? Yeah, it's moving it down 2 spaces. Now you can figure that out by making a table. So you plug in -2, -2 squared is 4, minus 2 is 2, and so on. Plug in -1, you get -1. Plug in 0, you get -2, and you will get those dots, which you're going to connect with a nice smooth line. Nice smooth, there it is. So that is what the graph of g of x looks like. Notice it's the exact same thing as f of x, it's just moved down 2 spaces. So it's f of x, but it's moved down 2 spaces. So the -2 just moves it down. That's it. All right, fantastic. Great example to add to your notes. Now let's jump into this one. So if you have 4x squared plus 1, compare that to if you just have x squared. So 4x squared plus 1, how is that going to compare to just having x squared? All right, let's see how you did. So the plus 1, I'll just move myself out of the way. We'll just see it. Now, one way to always do these is to use your lovely grids on the notebooks that we gave you on the graphs and make a graph. So you make a table, pick some values, you plug them in. If you have 4x squared, remember order of operations. You have to square the number first, then multiply by 4. So -2 squared is 4, times 4 is 16, plus 1 is 17. So when you plug in -2 here, you get 17. Plug in -1, you got to square it, you get 1 times 4 plus 1 ends up being 5, and so on. So the graph of this ends up looking like that. Now, if you compare that to just x squared, you'll notice it is skinnier, it's been vertically stretched, and it's moved up 1 space. So it's vertically stretched, it's skinnier, narrower, and moved up 1 space. All right, so make sure you understand, first of all, how to fill out a table like that using the values, and why it ends up being a skinnier graph that's been moved up based on the 4x squared plus 1. And if you've done all that, now we're going to move on to the next thing, which is if you have f of x equaling this, first of all, what is this -½ x squared going to do to our parabola? Just the -½ x squared part. Yeah, it's going to flip it over, and it's going to flatten it out because it's a fraction less than 1. So it's a flatter, flipped over parabola. What is the +2 going to do to the parabola? It moves it up 2 spaces. So it's going to be flipped over, upside down u. It's flattened a bit and moved up 2 spaces. That's what this one looks like. So again, you can get that by picking points and graphing them. They're doing the f of x part first. Actually, oh yeah, because that's what you should do, the f of x part first. So when you take the points and plug them in, you get those values, you get that graph. That's the flipped over, slightly wider and moved up 2 spaces graph. And then g of x is f of x minus 7. So what's going to happen to all of these points on f of x if g of x is that -7? If you said moves down 7 spaces, you're right. So g of x, everything's just moved down 7 spaces. You just subtract 7 from each of those values and graph it. And you end up getting the exact same parabola, just move down 7 spaces. And then the overall equation for this blue one, you can just say, oh, well, it's the original one minus 7. So you can combine the plus 2 and the minus 7 and get that right there. Okay, I know this was a lot, and I've just been talking and not really asking you questions. So I want you to study this page. Make sure it all makes sense. If you have any questions about it, make sure to ask me in class. You'll be working on this kind of stuff on big ideas. And now the last one is a story problem. So one way to solve this thing is to graph it. The other way to solve this is by factoring and finding out when t equals 0. So we have this function for an object that's falling from this 64-foot tall building. S sub 0 is the original height. It's 64. So this egg is dropped using this equation. Let's just skip through. Here's the equation right here. So it's negative 16t squared plus 64, because it starts at 64. And you want to figure out when it's going to hit the ground. Like, what is the time in seconds when the height is 0? So you can either solve this by graphing, so make a little table, plug it in, and solve it, or you can solve it by factoring. But I want you to see if you can figure this out. This will be open-ended, not multiple choice. Good luck. All right, let's see how you did. So if you made a table, at 0, it's 64. At 1, it's 48. And at 2 seconds, it ends up being 0. So when you plug in 2 for t, you end up getting 0, which means it hits the ground in 2 seconds. Yay. Okay, you could have also gotten that by factoring. So there is our last story problem type thing that you'll be working on here. So anyway, I know it was a lot of me talking. But if you have questions while you're working through the problems, first refer to your notes. And then just ask me. All right, good luck. I'll see you in class. Arr!